Hey, it's Mr. Allred here, and we're going to be talking about graphs of some of our common functions. So what I'm going to introduce you to here is what I like to call parent functions. And this sheet goes through the 5 basic parent functions that I'll use, and I'll try and explain them. You can probably just read them off the sheet. I'll make that available, but just in case you want an explanation, this will kind of go through it. So the first one I have here is the square function. This is the quadratic. We have graphed it different ways using the x and y intercept and the vertex, but we're going to reintroduce it here again and show a different way that we can use it eventually. But I can graph it just by calculating a few xy coordinates. So, and I plotted some common ones here. So -2 is an input, -1, 0, 1, and +2 as inputs. And I'm using a writing system I'm not familiar with, so it may not look as presentable as usual. But as I square these numbers, as I square -2, I get 4. Square -1, I get +1. Square 0, I get 0. Square 1, I get 1. Square 2, I get 4. I have those 5 points graphed over here, and as previously discussed, x squared makes a parabola. Okay. One we might not be as familiar with is the square root function. So f of x equals the square root of x. And keep in mind, we should have already talked about domain when we mention a function. And we talked about one of the limitations of domain was that we did not want a negative under a square root because we wanted to stay with real number system. So in that case, this actually has a domain, and if you set x to be greater than or equal to 0, you only get the right hand side of this graph. Now, as I pick some points to work with here, well, I can take the square root of any positive number. They're not always nice numbers, so they're not easy to plot. So I'll show you a few nice numbers here. The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. And I have those points plotted. Sometimes you'll hear square root graph referred to kind of as squirt, kind of abbreviation for square root, and it looks kind of like a little squirt coming across there. So we have the square function that looks like a U, and we have the square root function that looks like squirt if you take my word for it. The next two here are the cube function, f of x equals x cubed. I can't plot all these points on the graph that I have because I didn't leave myself enough room. But I could plug in the same thing as -2, -1, 0, 1, and 2. And if I cube all those, if I cube -2, I get -8, which if I was a graph would be down below my graph. But cubing -1 gives me -1, cubing 0 gives me 0, cubing 1 is 1, and cubing 2 is 8, another point that falls off the graph. But if I connect the points in a meaningful way, I get the cube graph that I have here. And notice it does go all the way up and down, where the actually x squared makes everything positive. So a little bit different meaning here. Okay, so refer back to these parent functions and what we're going to do a little bit later. The next one is the cube root function. I'm just going to basically turn around the x and y chart I just made for the cube. I'm going to plug in the common things here. So the cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And cube root of 8 is 2. Now the cube root does not have that domain restriction like the square root, because 3 negatives can give you a negative where 2 negatives give you a positive. So there is a domain limitation on the square root of x that we saw, but not on the cube root of x. Okay. So the last one I want to do down at the bottom, if I can get there, the absolute value function, absolute value of x. So I'll make a little chart here, plug in some x's, get out some y's, so know that the absolute value makes things positive. So I can plug in -2, and the absolute value of that is +2. Plug in -1, the absolute value is 1. Plug in 0, the absolute value is 0. Plug in 1 is 1. Plug in 2 is 2. So if I graph those points and connect them, we usually refer to the absolute value as being a V-shape. Okay, so it's a V-shape graph here. Okay, so out of the ones that I have, keep in mind that x cubed and the cube root of x kind of mimic each other in a way. I don't have a special way of listing them as far as their shape, but absolute value is a V. X squared, the square function, is a U, and the square root I call squirt. Okay, so that is the functions that we have that we'll be using to talk about other graphs.